I'm happy to announce today's speaker, Pradeep Kumar, presenting on the topic of AI Unveiled, From Origins to Ethical Horizons. And without further ado, I'm going to pass this over to Pradeep to begin his presentation. Take it away, Pradeep.
Thank you for the kind introduction, Jamie. And when I first started putting this deck together a month ago, I started putting content in there, and then I realized that I have way too much content. I didn't want to bore the hell out of you in one session. So this is going to be a two-part series. So the first part is going through how do we get here, right? I'll spotlight the significant breakthroughs that modeled AI, evolving from simple tasks to sophisticated systems capable of image recognition, natural language processing, and application robotics and creative content generation. So this narrative will still, accumulate with what's in store for us in the next wave. I'm going to just do the first two parts, which is how do we get here? I will explore the milestones from the 1950s when the term AI was first coined, and each of the milestones that brought us to where we are today. And along the way, I will demystify some flavors of AI. What is the hype today, right? The capabilities of language and image recognition has dramatically improved and is today at par with human intelligence. So although others might argue that the results are mixed, but on the whole, we have gotten a long way. From a level set, I'm going to go through a couple of things here first. First is what's the definition of artificial intelligence? They are basically fall into three types. The stage one, which we are in today, is called weak AI or narrow AI. It's a type of AI that's designed to perform specific tasks. Capabilities like Siri, Face ID, Google Assistant to self-driving cars, and the DeepMind board games are some examples of this narrow intelligence. So you basically train to do one thing. We have not gotten to stage two, but we're getting there. It's also known as strong AI or human level AI. Refers to a type of AI that understands and learns any intelligent task that a human can. Example would be a virtual assistant that can understand natural language, learn from user feedback, and handle complex tasks across different domains, right? So we're not quite there yet. And then the last one would be superintelligence, which refers to a type of intelligence that's much smarter than human brain in practically every aspect of self-awareness, right? In the second one, we are closer to that, right? One example that people are working on is a personal assistant that can manage one schedule, book travel, order food, and entertain with jokes and games, right? I mean, there are a lot of times to get there, right? As I'm going through the milestone, I want to clear up some basic concepts of machine learning. There are three main types. The first is reinforcement learning, where I would put it to an adventure going through a maze and figuring out that this particular route is not going to work, and so he will go find another route. So this is how the learner will interact with the environment and take action by receiving feedback, right? The second one is supervisory learning. It is akin to a child learning from a teacher. The methodology to do, say, a particular math problem, and when you come across a different math problem that has a similar types, they will be able to solve the problem. So unsupervised learning, on the other hand, is where you let the computer loose on, say, for example, images, and it will try to find patterns. So those are the three main types, and I will refer to those three along the way in the journey to where we are today, so that at least when I say those words, you could understand them. How did we get here, right? I'm going to go back in time to the 1950s when to the birth of AI, and they are attributed to these three main characters: Alan Turing, Marvin Minsky, and John McCarthy. Right? Alan Turing, you probably may have heard of him, and especially if you watch the movie The Imitation Game, he was responsible for breaking the Enigma code, the German Enigma code, that was considered unbreakable. And so he developed a machine that could eventually break the code that shot in the war. And he was also the one who came up with what's known as the Turing test. And the Turing test is basically this idea that if you give a computer, a human, a question and they both come up with the same response, then that particular software or computer has passed the Turing test, right? Of course, there is the more modern methodology, in some circles, which says, yeah, we need to update the Turing test. And one of the proposals called the ACI, Artificial Capable Intelligence, which basically challenge AI chatbots to utilize a seed investment of $100,000 and transform it to $1 million using various e-commerce tasks, right? So, this is almost like a tongue-in-cheek response to the Turing test, but some people are asking for that. In 1956, John McCarthy of MIT, who's the creator of the Lisp programming, was the one who officially coined the term AI at a DARPA conference. And then Marvin Minsky was influential in modern robotics. He was one of the first to develop visual scanners and mechanical hands with tactile scanners. But in the journey to AI, you see that we have gone through a number of AI winters, right? And what the AI winters are when nothing happened because people, there was not much investment and there was not much hope. So we went through these 2 AI winters, and my journey into this, this is the first one on the birth, and the next 3 phases are basically bookmarked by the AI winters. So in the first phase, in the 1960s, we have Frank Rosenbaum, who came up with what's called the perceptron machine, which is basically a machine that fills our entire room, and it is considered the first neuron. A human brain consists of 50 billion neurons, or so, something of that order, and it's a neuron that help us recognize things. And this perceptron was the very first one that can, by running different card stocks through the machine, is able to figure out what's marked on the left versus the right, and it can autocorrect itself, right? So that's the very first inkling of some kind of a neural network. And then came a computer program that can simulate human conversation. It was one of the very initial steps in the world of natural language processing. And then in 1969, we have Shaky the robot, which was one of the first robots with the ability to navigate environments. Next phase in Act 2 is the age of knowledge and expert systems, where you actually train the computer in a specific field. It's basically rule-based. You see this, it's that, right? So some of the very first implementations, like DXplain, is a clinical decision support system that can provide a ranked list of potential diagnosis based on symptoms, lab results, and other findings, right? Then we have Mycin, which is a system that identifies bacteria and prescribe appropriate antibiotics. And then, of course, we have the Perspective, which is designed to assist evaluation of sites or mineral exploration. And so we have a bunch of those kind of knowledge-based system in this particular era in Act 2. Then we entered another AI winter. After the second winter, we entered what's called the golden age of AI with the use of big data, machine learning. And I'll step through some of the key milestones, right? At the very beginning, the milestone is Geoffrey Hinton. He is considered the godfather of AI, right? And he wrote a seminal paper on backpropagation. It's a methodology. I'm not going to go into detail on how exactly it works, but it consists of input in a hidden layer and output layer, which has a feedback mechanism when you do supervised learning to teach it how to get better and better. This is akin to teaching a child by rectifying their mistakes. The systematic method empowered neural networks to refine their performance by learning from inaccuracies over time. One of the earliest applications using this technique was recognizing handwritten text on checks for bank verification. Today, it is used in facial recognition, voice recognition, healthcare diagnostics, financial fraud detection, game playing, and many, many more. And the next milestone from a pop culture standpoint was the defeat of Andrei Kasparov in 1997, but it was not using this big data analytics. It was still using the knowledge-based system. Essentially, what the Deep Blue computer did was they hired a couple of grandmasters and programmed this huge IBM Deep Blue computer that consists of 256 processors and is able to evaluate over 200 million positions per second, right? So I think that was when it first kind of in the public conscious that there's a machine that can beat human. And the next milestone in the world of robotics was in 2002, when the Roomba revolutionized household cleaning by bringing robotics into the residential domain. Created by an MIT robotist, the Roomba was not just a vacuum cleaner, but an intelligent device capable of navigating living spaces with finesse. Using reinforcement learning, the Roomba could avoid obstacles, glide around furniture, and ensure flows were spotless before returning to its charging dock independently. What made the Roomba stand out was its innovative features, such as an acoustic sensor that detects areas which has more dirt, allowing the Roomba to clean more thoroughly where necessary, cliff detection sensors to prevent the robot from tumbling down stairs or ledges, anti-tangle technologies to avoid getting ensnared in household nuisance like cords and carpet fringes, virtual wall technology which allow users to set up invisible boundaries the Roomba would not cross. In recognition for its impact, the Roomba was inducted into the Carnegie Mellon University's Robotics Hall of Fame in 2010. The honor celebrated the Roomba's significant contribution to robotics and is a testament to its enduring legacy in the field. And then from a autonomous car standpoint, in 2005, DARPA put together this autonomous vehicle competition. And the challenge was to go through a 131-mile route through the deserts in Nevada. And in the 2005 competition, nobody won, right? But in subsequent competition, there were four teams that managed to complete the entire route. So all this have a significant role in advancing autonomous vehicle technology and fostering the innovation in this field. So it later served as a catalyst for subsequent development in autonomous vehicle and robotics. One major milestone in the world of AI that was invisible to most people was a pivotal component that fueled a significant leap. That was the GPU, or graphic processing unit. This chart illustrates the trends in the share prices for NVIDIA, the foremost manufacturer of GPU. For those who need understanding the difference between a GPU and a CPU processes tasks one at a time using its limited number of cores. On the other hand, the GPU has thousands of cores capable of parallel processing, making it highly efficient for generating rapid graphics. Initially developed for the gaming industry as an accessory, CPU saw a revolution in 2007 with the introduction of a general-purpose GPU, propelling them into prominence for a range of applications that require heavy parallel processing. In 2010, we saw the first adoption of GPU in deep learning. So what is deep learning? The human brain has 86 billion neurons. Neurons are information messengers. They use electrical and chemical signals to send information between the different parts of the brain and between the brain and the spinal cord and the entire body. This branch of machine learning attempts to emulate humans using an artificial neural network to draw insights from a vast data set. This has application in image and speech recognition to natural language processing. With their adaptedness in matrix operation, GPU has become critical to the rise of deep learning application. I will soon discuss the first use of GPUs in a landmark image recognition competition that propelled deep learning into the spotlight. However, it is not an exaggeration to say that GPU has become a fundamental element in advancing AI. The very first time artificial intelligence, the concept of artificial intelligence, when you talked at dinner tables and bars and restaurants, that it entered public consciousness was a defeat of Brian Ritter and Ken Jennings in 2011 by Watson. And Watson is different. It was able to find answers from ambiguous clues, right? It has natural language processing capabilities and machine learning algorithm. So this was actually the biggest milestone that really where AI entered public consciousness. In June of 2012, Andrew Yang, a researcher at Stanford University, and his team at Google Brain built a network of 16,000 computer processors as an experiment designed to emulate the power of human brain using deep learning techniques. They then let it loose for 3 days on 10 million YouTube clips, and this brain did what any other human brain would do. Drum roll, like the human brain, it started to recognize cats. This computer cluster was able to determine what a cat is on its own, rather than being programmed to find cats. In September of the same year, AlexNet won the 2012 Large-Scale Visual Recognition Challenge. The purpose of this competition is to evaluate and automatically annotate photographs. AlexNet did not just win, it dominated. AlexNet, developed by Alex Proshevsky with AI godfather Geoffrey Hinton as advisor, used deep learning technique not unlike the previous example, but with the use of GPUs, two NVIDIA GTX 580 to be exact. Before AlexNet, deep learning has yet to gain prominence in AI research. Its success in this competition marked the beginning of what some would say the birth of deep learning search, profoundly influencing the trajectory of AI. And of course, 2016, that also brought a lot of brought artificial intelligence to consciousness, not in the United States, but the Asian market, is the game called Go. Unlike the chess competition, the number of moves possible on this game board is more than the number of atoms in the known universe. It is a popular game in Asia, in the Asian subcontinent, in China, in Korea, and Japan. A company in Denmark called DeepMinds developed a program that basically trained itself on online gaming. Basically, the funny story to that is that in the early 90s, when I was in college, I have a friend by the name of William Schubert who built the largest online Go gaming community in the world. And it was on the basis of 150,000 recorded games and 300 million moves on his game server that was used by DeepMind to train their machines. And then what they did with that is once a machine is trained using the supervised learning from the games that were held online, they have the computers fight each other. And when you fight each other, a process called reinforcement learning, they figured out things that no humans have done before, right? The reason why it also entered folklore in game 2, if you watch the movie, there's a movie called AlphaGo. You can go watch it. It's a free movie on YouTube. In game 2, move 37, it made a move that nobody saw coming, nobody could understand. Everybody thought was a crazy move. And it has always been analyzed and reanalyzed by computer scientists as eventually became the most brilliant move. It has also entered lexicon, like you want to do a move 37. A move 37 means doing something that's never been done before. The defeat of the Go player in 2016 was to the Chinese a Sputnik moment for them, right? And just like when the Russia put the first Sputnik in the sky, the defeat of the Go player. The Go has been played in China in the Asian continent for over 10,000 years. There were 280 million people watching the game online. And it was a big blow to their ego. And so from 2016, 2017 onwards, the Chinese spent billions and billions of dollars training people and putting classes together, putting schools together in the world of AI research. Today, China produced more papers on AI than the rest of the world combined. I would strongly recommend you go watch that movie. It's a pretty interesting movie, and it gives you a good concept of where machine learning is. But by 2017, they came with AlphaZero, and AlphaZero doesn't require any training at all. You give it any game, it will figure out how to play the game, and AlphaZero has beaten out AlphaGo. So in 2017, there was a paper by Google called Attention is All You Need. Basically trying to look at a lot of data. You need to have some kind of attention mechanism that can focus on a particular critical area, right? And I'm not going to go through this until the next phase, but basically the idea is to pay attention to areas that actually make sense. The transformers, the concept of the transformer model is the cornerstone for modern generative AI, the underpinnings, like the DALL-E, the ChatGPTs, and all that. So this was a foundation model that everything else came out from, right? DeepMind also came up with what's called AlphaFold for the human body has over 200 million proteins consisting of 20 different types of amino acids. And understanding the protein fall has a huge implication on how diseases spread and finding new drugs. The traditional methods such as X-ray, crystallography, and new MRI or NMRI would take months to determine a 3D structure of protein. Well, AlphaFold, on the other hand, can predict a 3D structure of a protein from its amino sequence without the need for experimental data. AlphaFold uses deep learning techniques and pattern recognition, can reduce the time for prediction to minutes or hours, and with the accuracy rate of 92% compared to the 58.9% in traditional method, right? So that was another big jump in medicine for drug discovery. Then, of course, in 2020, just before ChatGPT came up, we have this image generation with Stability AI, Midjourney, and DALL-E 2. It's using artificial intelligence techniques. Using the AI generators are available online, produce image from text description, and using a large database that pairs patterns with text. And now we have reached the final stop in this journey to the golden age of AI, ChatGPT. So what makes ChatGPT so special? The English language has a lot of interesting nuances in it. For example, we say things like the feet smells and the nose is running. That does not make sense because the nose is supposed to be for smelling and the feet is for running. ChatGPT is revolutionary because it is a generative AI model that can generate high accuracy and fluency with human-like text. It can generate imaginative and innovative content such as poems, songs, write code, essays, celebratory parodies, and more using its own words and knowledge. ChatGPT has the potential to revolutionize how we communicate with machines and interact with the world. And along the way, ChatGPT has surprised the world when it learned how to, on its own, how to speak in Bengali and other languages. And the fascinating thing about the adoption of ChatGPT is that it took only 5 days to get 1 million people and less than 2 months to get to 100 million people. And just when we are getting used to ChatGPT 4, 2 weeks ago, they released a new version called ChatGPT 4 Turbo. So let's examine what the what the differences are between the three of them. When ChatGPT first came out, the version 3.5, it can only handle text. The ChatGPT 4 has text and images using DALL-E. And ChatGPT 4 Turbo, in addition to text and images, can do text to speech and speech to text. The token size, which is the maximum number of words it can handle, the ChatGPT 3.5 can do about 6,000 words. ChatGPT 4 can do about 25,000 words, and ChatGPT 4 Turbo can do 100,000 words, which is about the size of a 300-page book, right? And unlike the two previous iterations, ChatGPT 4 is current up to April of 23, versus the previous ones were September of 21. And unlike the previous two models, the ChatGPT 4 Turbo give you the ability to create custom models and share with others. Because the additional modalities that ChatGPT 4 Turbo support, you can make it do more things. You can point to a portion of a human skeleton and ask it what the functions are for that part. You can point to an equation and it'll come back and explain the equation. You can pop open the hood of your car and take a picture of a particular part, and it will tell you what the function is. And the best part of the demo I saw last week is the automatic sports commentator part, which is a play-by-play of a soccer match. There goes the sportscaster's job. It can now do speech recognition via Whisper, V3, and any other language. And when you look at the continuum of artificial intelligence, the generative AI and specifically ChatGPTs and the bards of the world is just a tiny speck in this continuum, right? And in a future lecture, we will dive into what each of them are. And in the world of large language model. There are many, many players out there, and I peeled up about 8 of the most popular ones, and each of them have their own strengths and weaknesses, and 3 of the more common image generation tools. So what's next, right? I'm going to give you a couple of things that, and I'll recommend a couple of books, but some of the things that are going to happen in the future is this, among other things, is the confluence of IoT and AI. AI, the artificial intelligence, and the use of IoTs for medicine, for remote patient monitoring through wearable device, continuous visual tracking. Those are going to open up a new frontier in managing healthcare, right? And then the extended reality is the other one, where using XR, VR, mixed reality, and all that. These are in 2024 is going to be next big thing, right? And of course, 5G, AI, edge, and all that. Those are a lot of things that are coming down. But it's an exciting world. Digital twin, I don't know whether you have heard the concept of digital twin, is with the advanced telemetry that's coming from a human, and once we get to 5G advanced, where we get the low power radios out there, you can create a digital twin of, say, for example, an AQK patient online, and basically be able to detect things like, in the digital twin, the patient can detect when a potential heart failure is going to happen, the risk of hospitalization. It can be used to develop personal treatment plan. It can evaluate, genetic makeup, real time type of medication. What is the impact of different medication to the patient? It will do a real time analysis. Diabetes, a digital twin of a patient can, with diabetes, it can be used to monitor their blood sugar level, right, to predict when the risk of low blood sugar is going to happen, right? So those are some of the innovations that are coming down. And of course, this is further up, quantum computing, right? Quantum computing is a nascent field. There's working models by IBM, by Google, everybody, and anybody who has anything to say, including China. And here's the other part about quantum computing. There are more papers on quantum computing coming out of China than the rest of the world combined too, right? So that's the other paradigm, because they put a lot of money into it. A quantum computer is 158 million times faster than the fastest computer, and they can accomplish in 4 minutes what it would take a traditional computer 10,000 years to complete, which also brings about, the question about encryption, right? It's going to break encryption altogether really quickly, right? But this is still in nation state. The basic concept is, unlike traditional computing, which basically is binary, ones and zeros, there's something called the qubit, which can take many, many different states. It can be at 1 and 0 at the same time, and hence the reason why it's able to do this compute really, really fast, right? And of course, with quantum computing, the next phase is quantum internet, right? Which basically is 4,000 times faster than current internet rate. Is faster than the speed of light, right? So those are some of the emerging areas. So I'm going to close with a couple of recommendations. I talked about the Imitation Game, the movie. AI superpower, China's Silicon Valley and the New World Order. Kai-Fu Lee was an executive in Apple and Google and Microsoft. And this book does a pretty good job on describing the whole world of AI thing. The future is faster than you think. A book by founder of X Prize Foundation, Peter Diamandis and Steve Carter. What he did in this book is Moore's law, as we call it, has been not only been happening in computing, but in nanotechnology. In every field out there, we have Moore's law happening. It's a confluence of different technologies that's going to produce a new world order. In fact, it's funny because among the first chapter, he talked about flying cars. And if you saw today's publication, the first flying car has already made its test flight. It can convert from a motorcycle to a flying car in 3 minutes or less. What the future is faster than you think is a postulation of where we are going. What does the confluence of different technology types get you? The next book I recommend is A Coming Wave. Mustafa Solomon is the founder of DeepMind, and he have a very nuanced approach because One of the biggest warning in the book is about containment. The advanced AI is happening. When in the old days, when you develop a car, for example, right? When an accident happens, you figure out how to fix it and go along, right? But with AI, we are now opening a Pandora's box where we don't have the guardrails in place. And so he did a very good job of where the world is going, both the good and the bad. Dr. Lee's book from Microsoft is a good informative book on where AI is going to medicine. AlphaGo is a movie I just recommend to you. And then Chip Wars is a fascinating book on the history of chip development from the first transistors through the age of CPUs, all the way to current age of artificial intelligence and computing. And the control of this particular world is done by a few countries, right? For example, Taiwan Semiconductor is the world's largest producer, the foundry for the most advanced chips in the world. All of Apple chips are made there. And of course, this is this huge concern that is going to be attacked by China and what's going to happen to that foundry, right? And so it's a fascinating book. So these are some of the books I would recommend and to get you up to date.